Hello guys, you're welcome back to my channel. In today's video, we are going to be taking a look on a new topic in physics. As I have got promised that I'm going to be giving you tips on how to answer questions in physics, and likely questions that you can meet in your physics exams. Are you getting something now? So please follow with me and you surely get this right. So today, what I brought for you is projectile motion. I want to bring the question projectile motion for you in just only some minutes, and you understand what is there, everything about projectile motion. Now, what do I mean by projectile? I can easily define it for you as a two-dimensional motion of a body. Are you getting something now? We can have an application of projectile motion in the throwing of javelin. We are going to be taking a look on a new topic in physics. As I have got promised that I'm going to be giving you tips on how to answer questions in physics, and likely questions that you can meet in your physics exams. Are you getting something now? So please follow with me and you surely get this right. So today, what I brought for you is projectile motion. I want to bring the question projectile motion for you in just only some minutes, and you understand what is there, everything about projectile motion. Now, what do I mean by projectile? I can easily define it for you as a two-dimensional motion of a body. Are you getting something now? We can have an application of projectile motion in the throwing of javelin, the shooting of ball. Are you getting football? Are you getting something now? And also the shooting of missile. Just one example of projectile. Now, another example of projectile. Now, the reason is that when the bodies are moving, I said it is a two-dimensional motion. It simply means the kind of motion that is traveling in both the y-axis and the x-axis. The motion is always in this manner, like this, whereby it has a velocity. The velocity of the body is given to you. The body is always thrown at the velocity, it is always thrown with the velocity at an angle to the horizontal. Are you getting something now? So the velocity is u. Now you see this velocity has two components that you should know. Now it has two components of velocity. It has, because it is two-dimensional motion, it has an horizontal component of velocity and it has the vertical component of velocity. Now, every projectile motion will surely have these two components of velocity. And this velocity tends to increase. One is increasing and one remains constant. Now, when the body is in air, when the body is still in air, are you getting something now? This horizontal component of the velocity remain constant throughout the motion in air. Are you getting something now? The horizontal component of velocity, the reason why it remains constant is because acceleration due to gravity, is because gravity does not affect motion along horizontal direction. So when the body is moving along horizontal direction, the body is unaffected by gravity. So because of that, ux of the motion remains constant throughout the motion. Why uy of the motion keep on changing? Why? Because gravity there is a variation in velocity along the vertical direction when there is a change in, it is moving against gravity. Are you getting what I'm saying now? So from here now, in this case here, I have the body that is going here. This is my uy and this is my us. This us will keep on remaining constant until we get here. Now don't forget that this uy, and it is moving from the ground level, moving upward. Uy is then decreasing. Are you getting it? It is decreasing. So decreasing of this uy until it gets to this point. At this point here, my uy, which is the vertical velocity, equals to 0. Are you getting it? So it has a final velocity there which is equals to 0, but the us remain constant. Now, and this is something that John are kind of tricky nowadays. Now they might ask you a question on this. Are you getting what I'm saying now? Which of the following component of velocity remain constant when the body is moving when the body is performing in a projectile motion? Which of the following component of velocity remain constant in a projectile motion? Then I'll be giving you the horizontal component, which is us, the vertical component, which is uy. Please note, horizontal component of velocity has no acceleration to gravity. Gravity has no effect on horizontal component of velocity. It only has effect on the vertical component of the velocity. Take note of that. I think I've been able to explain that. Now, when you're moving down, this equals to 0. Then when it comes down like this, the body started what? Going down. Velocity is what? Uy. And this remains ux. Altogether, throughout the motion. I think I can have the what? The resultant of the two velocity. These are resultants. The resultant is like this is my u. Altogether. Now, what are the major things that you can find in this thing? What are the major questions that can be given to you in this? Okay, before I move on to that, I said the horizontal component of the velocity ux. Let me write it down here. Ux is given as what? U cos of theta, cos of angle of projection, and the vertical component of velocity is equal to u sine of what? Theta. Please take note of these two things here. Now, what are the major things that can be asked from you in projectile? Because whenever I want to give a question on projectile, it should surely be calculation. Now, what are the major things that you can see there? The first thing is the maximum height that the body reaches. That is the maximum position that the body reaches before the body starts to drop. Are you getting what I'm saying now? And they can also ask a question on the range of the projectile. The range simply means the horizontal distance, the total horizontal distance covered by the body, while the maximum height is the total vertical distance covered by the body. Are we together? So take note of this. Another thing that you can be asked, I'm thinking I'm writing it out, the range of the projectile, the maximum height of the projectile, and the third thing is now the time of flight. Time of flight of the projectile, range, time of flight, and the fourth one is now, you might be asked question on the time taken to reach maximum height. Time to reach maximum heights. Maximum heights. And then the fourth thing, you might be asked question on what is the velocity of the body when it's dropped back to the ground. The velocity of the body on the ground here will be equals to what? V. Sorry, find the velocity of the body when it dropped down. Now let's take a look at this one by one so that you understand. And I'll pick out what normally asks you here. Now, for the maximum height, the equation for maximum height of a projectile is always equals to u squared sine squared theta all over 2g. That is the maximum height of projectile. Now, why? The question again for range of a projectile, you might be asked to find the range. The range of a projectile R is always equals to u squared. It has the same formula. U squared sine 2 theta over g. Now let me try to analyze these two formulas for you so that you understand what you want to use. Many people understand, they know the formula, but usage of the formula is another issue for them. Now take note of this. Whenever you see something of this sine squared theta, it simply means if you are to solve it in jamb or in any exam, this should be done first, sine of the angle, then your answer should be squared. So here this simply means sine squared theta means sine theta squared. But if you have this, sine 2 theta is equals to sine of, multiply the 2 to the angle first, anything you get, find the sine of the angle. Are you getting this thing? That is what is there. And take note, any angle that they are going to be giving, they will not give you the angle that cannot be found that you cannot solve easily with your brain. Are you getting it? The angle that will be given to you in JAMB are only special angle. And what are the special angle? Angle 30 degree, angle 45 degree, are you getting it? Angle 60 degree, angle 90 degree. Are you getting what I'm saying? 90, but majorly they might not even give you 90. Their major angles that will be given to you is what? 30 degree, 45 and 60. And because the reason for that is because it is easier for me to find the sine. Sine of angle 30 degree is always equals to 1 over 2 without memorizing it. Sine of angle 45 degree is equals to root 2 over 2. While sine of angle 60 degree is always equals to root 3 over 2. Let me give you another trick of finding this angle. If you want to find, maybe you find what? Forget it. You can easily solve this angle by using your fingers. How do you find what? Angles using your fingers. Now, I think there is a formula for it. And that formula is this. If I have something of this kind, I can easily find the angle by saying sine of any angle is equals to square roots of fingers, sorry, let me use like this. Fingers before folded finger, before folded finger, folded finger, all over fingers, sorry, all over total fingers. Left unfold, left unfold, unfold. Now, this is what we mean by that. You see, if you have to find what sign of angle, it has this thing. You see, this is my left hand here. I have this, my smallest, listen here, to the angle 0 degree. This is angle 30 degree. This is angle 45. This is angle 60, and this is angle 90 degree. All together. So, if I'm asked to find sign of any angle, like let me say sign of angle 30 degree, for instance, I want to prove out this formula for you. Now, sign of angle 30 degree, notice this is 0, this is 30. I'm going to fold 30. I'm going to fold 0 degree. Now, what is this finger? Sorry, sorry. Yeah, I'm going to fold this. Now, this is the finger before the one that I fold, and unfold. This one is the finger after the one that I fold. Are you getting what I'm saying? So, the formula is sign of any angle is equal to finger before the folded finger all over total finger left unfold. Total finger that is not what? Fold. That's what we call. Now, this is the finger. How many fingers is left? I have one finger before the folded finger. I have sign of angle is equal to square root of 1. All over total finger that is left unfold is 1, 2, 3, 4, which is over 4. I should be having square root of 1 over 4. That will be equals to 1 over 2, because square root of 4 is 2, square root of 1 is 1. So sine of 30 degrees is equals to 1 over 2. I think I can do that for 45 degree also. For 45 degree, you know this is 45, I'll fold 45. My unfold finger is 2. So the folded finger before the folded finger is what? 2. I have square roots of 2 over the one unfolded, that is 4. All over 4, I should be having square root of 2 over square root of 4, which is root 2 over 2. All together, and that you can do that same thing for sine 60 degree. I think you are going to get the same thing. That is that for that. So you can easily use my formula to find your sine, which are what you are going to be given in graph. So if you are not given any, you can only be given this. Why? Because there is no calculator. So they expected you to understand how to use these trig functions all together. So I think the range of projectile will be given to you. My G indicates acceleration due to gravity, which will also be given to you. Your G will be equal to 10 meters per second. Try to memorize that also. Now, the time of flight. The time of flight, sorry, let me try with this. Alright, let's remove some of these diamonds. Now, the time taken to reach the maximum height, T, is the time it will take the body to move from here and get to this maximum height before dropping. The time taken the body will move from point O to point A before it drop down. That is the time taken to reach the maximum height. And it's always given as U sine theta all over G. This is the time to reach what? Maximum height. Now take note of something. The time to take the body to reach the maximum height is always equal to the time to take the body to drop from the maximum height. That means T to T, how about 2T, 2T. Now this total time that the body, this time taken is the total time the body spent in air. And the total time the body spent in air is known as the time of flight. So time of flight is always equal to 2 times time it will take the body to reach the maximum height, which is equal to U sine theta all over G. This is our time of flight. So according to the definition, time of flight is the time taken, is the total time taken spent by the body in air. That is our time of flight. So, you may ask any of this formula. That is another this thing I want you to note. Now, what's another thing that I should know that question might come out from it? I think this is my maximum height. This is my range of projectile. Now, I noticed something that some of their questions are also coming out on maximum range. I think I saw a question about at what angle does a body have what? Maximum range. Maximum range always occur when the angle theta is equal, when the body is projected at an angle of 45 degrees. When the body is projected at an angle of 45 degrees, then the body will have a maximum range. And in that case, my maximum range, R maximum, please, they can give you this. You can have a maximum range when theta is equal to 45, or when 2 theta is equal to 90 degrees, or when sine 2 theta is equal to 1. They can give you any of this condition. Each of these three conditions signifies maximum range altogether because they are the same. If I substitute here sine 2 theta, when my theta is 45 degrees, if I put it here, 2 times 45 is going to give me 90. So 2 theta represents what? 90 here. So, sine 90 is 2 theta. So sine 2 theta is equal to 1, which is still the same condition. All together. So from here, maximum range of the projectile should be equal to u squared all over g. Please take note, this is different from this. U squared over 2g. This indicates maximum height also. The maximum height of the body that is going, when you throw a body upward. The maximum height reached by the body before it is what? Dropping. This one is when the body is not thrown at an angle. So we normally have this formula for vertical motion, motion under gravity. Vertical motion of the body. Take note of this. And take note of this maximum range of projectile of the body. All together. Now, that is that for that. Now, another thing I noticed that sometimes they must give you a question in which you have to find the range of a body. Are you getting something? And you're given the time of flight. Take note, the range of a projectile only depends on the horizontal. I said this velocity has two components, the vertical component and the horizontal component. You see, the vertical component is used to determine the time of flight, the time to reach the maximum height, and the maximum height. But you see, the range of a projectile is only determined using the horizontal component of the body, of the velocity. Why? Because the range is only showcasing the distance traveled along the horizontal direction. So, and as to find the range of a projectile, range can be calculated using range of a projectile is equal to what? Horizontal component of the velocity multiplied by the time of flight. It is also the range of a projectile. You can calculate it using this. Are you getting me? This is one type of projectile. Projection at an angle. Now, what about, I think there are two types of projection. We can have a projection at an angle, and we can have an horizontal projection. Now, questions are also coming out from horizontal projections. Horizontal what? Projection. In that case there, I have the body like this, whereby the body is being fired with an horizontal velocity, like this. It's coming like this. I have my u horizontally. The major question they normally ask here, because the body is fired at an height h. Note that they fire the body at an height h. We can also find the range of the projectile, the range of this, because this is the point of what? Firing, and this is the point of landing. So automatically, this body has a range. We normally have this thing. If you have a tap that is just gushing out, water is just gushing out from the tap. Initially it will have what? It's moving along the horizontal direction before it will bend completely and come down. Are you getting something now? Now, this is it here. Now, this is the range of the body. How do we find range in this case? When the body is not projected at an angle, it is easy to find. Now, please take note of this. We can also find the time of flight here. Time of flight is the time taking the body will spend in air. And the time of flight in this case here is not the same as the initial time of flight. How do we find the time of flight? That's what I want to know. Because I said earlier on that the time of flight depends on the what? Vertical velocity. But the velocity given to us here is the horizontal what? Velocity. We can easily find our time of flight if we are given the range, because the range of a projectile is horizontal component of the velocity multiplied by the time of flight. So time of flight can be gotten from here as range over what? Horizontal component of the velocity. That's our time of flight. Sometimes we're given the time taken. So this is the major formula we're going to be using. Horizontal component of the velocity multiplied by t. And the horizontal component, don't forget that u is t minus u, because the body is projected at an horizontal angle. Are we together? Now let's take an example on this, because I said I promise you I'm not going to be spending much time to explain this so that you understand everything about this and where questions can be asked for you. Now, I think I've been able to analyze what is here. Now let me try to use an example so you understand what I'm trying to say here. Now, I'm trying to use a past question which is known as our jamb series. That's what we use in this my tutorial. Now, I think I have this question here. It said, a projectile is fired from the ground level with a velocity of 300 meters per second at an angle of 30 degrees. The velocity of firing, that is my initial velocity, is 300 meters per second, and then at an angle of 30 degrees, theta is equal to 30 degrees, and then your g is constant as 10 meters per second square. Now, then I said, calculate the time taken to reach the maximum height. How do we find the time to reach the maximum height? Let's take it as t. Don't forget that the time to reach the maximum height is given as u sine over theta all over g. Now you get something now? So this is the time to reach the maximum height. So from here, what's my u? My u is 300 multiplied by sine of my angle theta is 30 degrees all over 10. I think I can easily say this cancel this. I'll be having 30 multiplied by sine theta. Sine 30 is equals to 1 over 2. So over 1, 2 cancel this. I'll be left with what? 15 seconds. All together. So the time for the body to reach the maximum height is 15 seconds. Now let's take the second question. Another second question that is set under projectile in jamb that I saw for this year. He said, a football is hit with a velocity of 6 meters per second. A football is hit with a velocity of 6 meters per second. That means u is equal to 6 meters per second. And then, at an angle of 30 degrees to the horizontal, theta is equal to 30 degrees to the horizontal. The time of flight of the ball is what? What is the time of flight? T. We don't know. Now, how do we find this? Don't forget that our time of flight is twice of time to reach maximum height. So I can say 2u sine theta over g. So I should have been 2 times, my u is 300, my u is 6 sine 30 all over 10. So that should be equals to 12 times sine 30 is equals to 1 over 2 over 10. So 2 cancel this, I'll be having 6 over 10. So divided by 12, that is 6. Divided by 10, that was given was 0.6 seconds. So the total time of flight is 0.6 seconds, which is our answer. Now, that's that for that. Thank you for watching this video. Please don't forget to like my video and also subscribe. If there is anything that is bothering you that you don't really understand, drop a comment for me on in the comment box section below. I'll surely respond to your comment. And please comment on my videos and share with your friends, share with everyone so that they can also have the basic knowledge of this in a simplified manner, just like this. Thank you so much.